This last page of notes shows us some applications for log expansion. This first part on the top here are problems that often appear on SAT exams or places where they want to assess log expansion rules, but you're not allowed to actually use a scientific calculator. So what they typically do is they will give you some expression or even a made-up number to evaluate or substitute for some log value. So in this case, they're telling us that log 2 is A and log 3 is B. Other things that you always want to remember is that whatever base of the log they're giving you, in this case 10, we know that value as well. So in this case, log of 10 or log base 10 of 10 is 1. And we can also often use the fact that log of 1 is 0. For each of these examples, what we're going to do is we are going to rewrite the argument of the log. So be it 2/3, 0.5, 6, or 20, we're going to rewrite each argument in terms of the given logs that they tell us and our always known logs. So for example, on log 2 of 2/3, we notice that the numerator and the denominator of the argument are in fact the values that they've given us. So this particular problem could be rewritten as log 2 minus log 3, in which case we would look up above and we would just do a simple substitution. Log 2 is A, log 3 is B, so our final answer is simply A minus B. For log of 0.5, we would want to rewrite that as a fraction first, so log 1/2. Now I can see the 1 that we've already established from up above. I can see the 2 that I'm looking for that they already gave me, so I would expand again. So I would say log 1 minus log 2, and then substitute. Log 1 is 0, log 2 they tell me is A, so my final answer is negative A. Log 6, we need to get a little bit more creative. We need to rewrite the argument using 1, 10, 3, or 2, and we are only allowed to use exponents, multiplication, and division. So log 6, I know, could be written as log 2 times 3. Those are the two numbers that I was looking for. Expand again. Log 2 plus log 3, substitute again, A plus B, and we're done. Log 20, again, multiplication, division, and exponents are all we're allowed to use, and this has to be, the only values that we can use are 2, 3, 10, and 1. So log 20 is going to be rewritten as log 2 times 10. Log 2 plus log 10. Log 2 is A. Log 10 is 1. And I'm finished. So those problems are usually pretty quick and simple. They sometimes require a little bit of creativity for how to rewrite the log, but they're usually quick substitutions. The last one is an additional exponential problem that we did not look at before that we can apply our expansion rules to. So if we were going to analyze this problem from the beginning and from the perspective that we did at the beginning of this chapter, what we would notice is that these bases cannot match. There's no way we can write 5 and 3 with the same base. So our problem with the problem is that we can't match the bases. In the past, what we would have done is we would have had a scenario where we couldn't match the bases, but only one side had an exponential. In this case, both sides have an exponential, and we can't get the bases to match. So what we're going to do is actually take the log of each side of the equation. Remember, a log is simply a mathematical operation. So I'm going to rewrite this problem, and I'm going to choose natural log simply because it's shorter and faster to write. Natural log of 5 to the x minus 2 equals natural log of 3 to the 3x plus 2. And if we want to write ourselves a note of what we did, we log each side. Then we're going to now use our expansion rules. So we're going to take our exponent and we're going to write it in the front. So I'm going to have x minus 2 with parentheses around it, natural log of 5. And 3x plus 2, put some parentheses around it, natural log of 3. Write myself a note. What did I do? I expanded the log. It's important to remember that natural log, although it looks like a variable, is actually a number that we know in our calculator. So I can distribute my natural log and write x natural log of 5 minus 2 natural log of 5, 3 natural log of 3x. I'm just going to put that x at the end. It's a little easier to see. Plus 2 natural log of 3. Distribute. Then we are trying to solve for x. So similar to what we did when we were solving inverses, I'm going to take everything with an x and move it to one side. So I'm going to have x natural log of 5 minus 3 natural log 3 of x equals 2 natural log of 5 plus 2 natural log of 3. Isolate x. And we're actually almost done now. Factor out the x. And then we just have to divide. So our final answer, although it's going to look super crazy, almost forgot to write the 3, looks like that. Now this is what we would call the exact answer. But we can also do a decimal approximation, and you should try to type this in your calculator and make sure that you can actually get this approximate answer. If this question were on the final exam, since we are not using a calculator, this is what we would call our calculator ready form, and this is what they would show as one of the choices.